Hello everyone, I am happy to welcome you to the second session hosted by Globima at FME World Fair 2021. My name is Karolina Borkowska and I am a product manager of FME and I will coordinate this session. During this time, our expert will tell you how to use the possibilities of FME in telecommunication companies. First of all, I would like to tell you about all the Globima activities during the FME World Fair 2021. We prepared 3 plenary sessions in which presented our customers and our employees. The first session conducted the top use cases of FME platform in government sector. There you can hear practice use cases from our customer from the head office of Geodesy and Cartography, board of Geodesy and Town Cadastre in Poznań, and municipal planning office in Łódź. In the second session, in which you are currently participating, we will talk about the use of FME in several projects implemented by our company in cooperation with our telecommunication customers. And the third one about the use cases from architecture, engineering and construction session. And during this session, we'll present one of our customer from VisiMind company and one of our employee from Romania. We are planning a live Q&A session during which you can ask any question about presented use cases. The URL to this session you can find in each session description. The Q&A session for this plenary is planning for May 11th at 1:30 p.m. in Central European time zone. Of course, as a co-host of this event, we have a virtual pavilion of our company. Enjoy visiting and meeting us. On our pavilion, you can find our employees from our few branches and you can schedule a meeting with anyone you want. At Globima Pavilion is present Bartosz Lech, who is a head of location-based services department, and he is from our main branch from Poland. And at the pavilion is also Joel Swanson from Globima USA, and he is a business developer leader, and they help to find the best solution for you and your business. At the pavilion, you can also find me, FME Product Manager, and Wiktor Sawicki, Key Account Manager. He knows all about FME licensing, model subscription, and he helps you to find the best solution for you and your company. We are working in the main Globima office in Poland, but of course, everyone can contact us wherever you are from. FME expert at our pavilion will be Mateusz Pyra and Paweł Wrblewski from Polish branch of Globima, and Nicolae Sorae from Globima Romania. Mateusz and Paweł are geospatial data specialists, and Niku is IT consultant, and all of them have FME certified professional. Additionally, Mateusz has FME server certified professional, and he is a trainer of FME. You can ask them about all of the technical issues of FME. Okay, I think that we can start our session entitled How to Use the Possibilities of FME in Telecommunication Companies. Use cases from the European market. During this session, we'll be present 2 presentations. Both of them will be delivered by employees from Globima, and they are a part of projects realized by us. On the slide, you can find the titles. The first one, Making a Better Informed Business Decision by Merging 3 Databases into one GIS, and the second one, Generation of Mobile Network Range based on the location of the cell towers. Any question about this presentation you can ask during the live Q&A session, which is planning for May 11th at 12:30 p.m. in the Central European time zone. The URL for this live Q&A session you can find in the session description. Before I will invite the first speaker, I would like to talk a few words about Globima and our experience with FME in telecommunication. We are an IT and geospatial solution provider since 1993. Some of our solutions are network inventory, field service management, solutions-based Google Maps and Google Platform, data management, and many more. We have offices in Poland, Romania, Czechia, Serbia, and the USA. We are a safe software silver partner since 2013, and our employees are FME experts. They have FME certified professional, FME certified trainer, and FME certified server professional. We are also FME industry expert for architecture, engineering, construction, for government, for telecommunication, energy, commercial, and utilities. We conduct FME trainings, so we can also develop and help to improve your business based on data integration and process automation using FME. Okay, it's time to start the show. The first speaker is Nicolae Sorae from Globima, Romania, and as I mentioned before, he is an IT consultant and FME expert. His presentation is entitled Making a Better Informed Business Decisions by Merging Three Databases into One GIS. I hope it will be a great experience for you.
Hi. In today's presentation, we will tackle the subject merging three databases into one GIS. And the project was deployed at one of our customers, Telecom Romania. Telecom Romania Communications is a Romanian telecommunications company based in Bucharest, and it was launched in September 2014. The main fields of its activity is Internet and IPTV television. Few words about myself. My name is Nicolae Sorae, and I am working as an IT consultant in Globema, Romania since 2009. During this time, I was involved in many projects in which I used FME for data manipulation. Agenda for today's presentation. We will start with issues that were raised by our customer and the objectives they had, challenges we faced, solution we delivered using support from users all over the world, thanks to FME Community. We will talk also about the results and benefits of using FME, and we will wrap up with some conclusions. Especially when regulatory began to asking for details, information regarding spatial data in the network, all database had to be updated with data from other sources outside GIS. Globema used FME to convert, analyze, and manipulate data in order to unify all infrastructure plus network and addresses data inside one single database in a short amount of time. After our multiple discussions with Telecom Romania on this topic, we received a request for solving following issue. Telecom intends to update and correct data inside smaller PNI, physical network inventory, with new addresses for the whole country according to latest information addresses exported from Telecom's master address database in Excel format, and also from other set of addresses data in DWG format. At that time, we had three databases containing addresses: physical network inventory, DWG, and Excel files. The main objective was to gather all addresses in smaller physical network inventory and eliminate all the duplicates resulted from merging all data from three sources into one single database. First objective was to generate address numbers, because in data coming from address database from customer, we had only minimum even and odd plus maximum even and odd, along with the numbers of even and odd numbers on each street. Starting from this information, we needed to generate address numbers. The second objective was to eliminate duplicates because we had lots of cases with duplicate numbers or human mistakes when the street name was written wrong or with some missing letters in one of the sources. Merging together the data sources could have caused duplicates, for example like St. Patrick with K or St. Patrick without a K with a C, etc. Manual correction was also needed here. The third objective was to update smaller database with clean data. So, at this point, we downloaded all address data from PNI into just one single FFS file and rejoin it with the data from the XLS file, from Excel file, and also from DWG file, and uploaded it back in smaller database. What challenges we faced? Thanks to great people from FME Community, we managed to process using FME Desktop the Excel file by adding a separate column in the table containing address numbers, odd and even, based on the values given to us from the fields minimum even, maximum even number, minimum odd number, and maximum odd number. As a result, the address numbers were generated, and it will be imported in PNI as described later on. At this step, Globima developed an FME script that will compare addresses from different tables. Address database versus PNI. It will prior generate FFS file from smaller PNI that will contain all existing addresses and won't be duplicated. After comparing these two tables, records found in address database table and not found in PNI table will be processed automatically in the template used by smaller PNI and uploaded into the database, including generated address numbers. Using FME Desktop, we also identified the cases when records were almost duplicates. For example, as we said earlier, missing one letter from street name, and helped us and the users from Telecom to manually correct the data inside the small word PNI. The solution? So basically, our solution included data analysis from all three sources. And we eliminate duplicate and move it into one single location where most of the departments can take advantage of it. In our case, all three operations, analysis, duplicate elimination, and database bulk update, was possible using the solution, FME Desktop. For each county from Romania, just to describe here a little bit in more details the solution, the customer delivered to us the Excel file with address data from local address database. Globima, us, will process using FME Desktop the Excel file for that certain county by adding a separate column in the table containing the address number, odd and even, based on values from fields maximum even, minimum odd, and maximum odd number. As a result, the address numbers are generated and will be imported in PNI as described. In the next step, we developed an FME script that compares the addresses from different tables. From this database with addresses, master address database, versus PNI, physical network inventory. It will prior generate an FFS file from smaller PNI that will contain all existing addresses and won't be duplicated. After comparing these two tables, records found in master address database table and not found in PNI table will be processed automatically in the template used by smaller PNI and will be uploaded into the database, including generated address numbers. Using FME Desktop, the list with streets that are inside master address database but not inside PNI will be also uploaded in PNI database. Address numbers will be imported in 3 steps. Step 1. Bring locally in Excel files all the streets and cities from PNI database using FME desktop. So we actually made here an export from PNI smaller database in Excel files. The second step, we selected the city we are working on and generate all the streets from this city. Data is read from the Excel file generated in this phase, described at point 3 at the previous point. Table with new addresses, existing streets from the city we are working on, and the data is mapped street with addresses and inserted back in PNI. Some tips we have here for you. Well, we had our challenges as we discussed few slides earlier, but every time we needed help we used FME Community, where we read tutorials, met savers, had discussions, and even commented about what we would like to see in our upcoming versions of FME. So it's safe, it's okay to use FME Community if you have if you are facing some challenges, if you have some questions, if you don't know how to do a task. It is the best solution to find answers regarding FME. Results? Well, the results from you can see also the results here in the monitor from my slide. Streets from addresses database and DWG files are now imported in smaller PNI. It's true that some manual editing work can also be performed because the Excel file was not 100% accurate. However, the percent of errors was not that big. Volume for introducing data was reduced from, let's say, 1 month per county to 1 day per county. So it's huge improvement. The conclusions. So the net result here was that FME solution has the advantage of being fully scalable, and it can be easily used for a city, county, or entire country. And we can say here that the results met or actually exceeded the customer's expectations. And the time spent for introducing data was reduced with more than 90%, thus including customers' efficiency. And the benefit here is that they can make better informed business decisions by merging this 3 database into one single GIS system. So the benefits were huge. Well, thank you very much for your time. This was my presentation, and we can meet in Q&A sessions. Thank you.
Thanks, Nico, for your presentation. If anyone has question about this topic, we invite you to a live Q&A session, which will start on May 11 at 12:30 p.m. in the Central European Time Zone. Now, I would like to introduce the second speaker of this plenary session. In front of you, Paweł Wrblewski from Globima, Poland. I told few words about him in the first part of this session, but I will remind you. Paweł is a geospatial data specialist and FME certified professional. He will present the topic, Generation of Mobile Network Range based on the location of the cell towers. Enjoy the presentation.
Hello everyone, my name is Paweł Wrblewski and welcome to the FME World Fair 2021. To begin with, I would like to thank previous speaker for a very interesting presentation, and the topic of my presentation is Generation of Mobile Network Coverage based on the location of the cell towers. The project was done on example of Estonia because Estonia provides official data about mobile phone network, so it was possible to verify the final results. As I told, my name is Paweł Wrblewski and I work in Globima. I have been working at FME for over 6 years, and I use it for migration, data analysis and broadly understood data processing. In order not to distract you, I'll turn off my camera. At the beginning, I will present the scope of my presentation. First, I will discuss the principles of designing a mobile network. Then I'll discuss the available technologies and their ranges. Next, I'll discuss the principles and rules on the basis of which the theoretical model of coverage of the mobile network was created. Later, I'll discuss the created model. Finally, I'll talk about the principles of verification of the created model and the possibilities of its future development. What is most important when creating a mobile network? Of course, the location of cell towers. Each operator strives to maximize coverage country with his towers. The density of cell towers depends on the transmitter technology used and the nature of the area in which it is located. In addition to the maximum coverage of the country with the range of their transmitters, operators also strive for signal redundancy. Redundancy is a situation when you have access to the signal from several cell towers at the same time and location. In densely populated area, the number of towers is greater than in less populated areas. To obtain greater coverage of the country, operators in sparsely populated areas often use transmitters with lower bandwidth but greater range, mainly in GSM technology. In urban areas, operators mainly use transmitters with shorter range but greater capacity, mainly in LTE technology. Finally, it is important to mention the influence of topography and land cover on signal coverage. The more developed areas have more the signal interference and shorter range. In the presented model, topography and land cover are not included. What elements are included in the presented model? Cell towers with location and attributes, cell tower signal coverage, buildings with information about available network providers. These slides show the overall flow of the model creating process. The source data were buildings from OSM and cell towers with location and attributes. Combining the knowledge of network designing with FME capabilities, a theoretical model of mobile phone network was created. In this slide, we can see the general flow of the process. On the left side, we can see the data loading section and the preparation of data for analysis. In the middle, there are sections where the analysis was performed. The analysis was performed mainly using spatial analyzing tools, for example, point on area overlay, special filter, etc. On the right, we see the resulting data storage section and section where we testing the credibility of the result model. How the analysis of tower density in mobile network was performed. Estonia's area is divided into squares with side of 5 on 5 kilometers. Then it was checked how many cell towers are in the analyzed square. The analysis was performed separately for each operator. Based on the result of the analysis and knowledge of transmitter technology, theoretical country coverage buffer was created. The basic tool for performing the analysis is point-on-area overlay. A list was also used to obtain the final results. And all data from various sources were combined using the feature joiner. To increase the speed of the analysis, all unnecessary attributes have been previously removed. In this picture, we can see flow of analyzing process. The result of the analysis were the basic for creating a country signal coverage model. Based on their data and knowledge of network design, buffers were created showing the range for individual cell tower. Depending on the location of tower and technology of transmitter used, the buffer's radius have different value. Depending on the density attribute and transmitter technology, 7 different coverage buffers were created. The buffer transformer was used for this purpose, and the buffer radius were created as conditional expression. On this slide, we can see the dependence of the buffer radius on the density of tower and technology used. The buffer radius range has value from 12 kilometers in sparsely populated areas to 750 meters in urban area where is LTE technologies used. In this picture, we can see the coverage of phone towers in Estonia. We can see coverage of the whole country with the signal. Only small holes are visibility in sparsely populated area, in forest, lakes, etc. Based on this analysis, we created a data model where each building knows which tower it is within, each building knows which operator can provide services, each building knows about the nearest cell tower and distance to it, every building knows about the transfer technology available. How did we find all towers for selected addresses? First, we remove all necessary attributes to increase speed the analysis. Next, we used point-on-area overlay to find all towers depend on building. We use list to find all towers providers and technologies, and last we used neighbor finder to find the nearest tower for the building. The result of the FME script is a Geojson file containing the following data: cell towers list with location and attributes, list of cell towers available at selected address, list of providers available at selected address, signal technologies available at selected address, nearest cell tower, and distance to it. In this slide, we can see the final data model where the maps show the mobile network points, cell towers, and telco access point. Each cell tower has information about operator and which transmitter has been installed on it. Below, in the table of attributes, you can see each access point which knows from which tower it has a signal. also know which tower is closest to a selected point. Based on this table, you can read the name of operators available at selected address point. Additionally, each address point know what OSM building it is on, because it has the OSM identifier. As I said at the beginning of the presentation, the mobile network model was made for Estonia for a reason. The website neticard.ee provides data for each address point. Each address point has information which operator can provide the service at this address. These are official government data. The comparison of official data and data about cell towers made it possible to check the credibility of the network model. The comparison was made with Attribute Manager using conditional value. The comparison was done separately for each operator, and finally results for all operators were combined. Based on the analysis of the calculated attributes, the reliability of this model was approximately 95%. Finally, I should mention that the presented model is not closed. It can be expanded with topography data, land cover, and detailed data about technical parameters of the network. The data model can be developed for the impact of the power network on the mobile phone network. Complementing the attributes of a cell tower with information how it is powered, we can predict the impact of a power network failure on the mobile phone network. Finally, I should talk a few conclusions. Using FME, you can create a model of a mobile phone network. To create a model, you can use data from various formats and various sources. FME enabled the creation of realistic model based on the partial data. The high degree of compliance with reality was confirmed by comparing the generated model with official government data. Finally, I should mention that the model shows only some of the possibilities of FME. Adding to it topography data, land cover, it can be future extended, creating the most reliable. The model extends with land cover, detailed data on the device used, can be helpful in network development and design new solutions. Thank you for your attention, and please ask me any questions. If you want, you can contact with me by email. My address is visible on the presentation, and I wait for any questions. Thank you.
Thank you, Paweł, for presenting this interesting topic. And of course, if anyone has questions to Paweł, feel free to join us during the live Q&A session, which will start on May 11th at 12:30 in the Central European Time Zone. That's all on this session. I hope you had a great experience and find new possibilities to use the FME platform in your business. Thanks for your attention, and we invite you to our pavilion. There you can meet us. Of course, we encourage you to join or watch a recording of our other session for government and architecture, engineering and construction. If you cannot visit us at Pavilion or join to live Q&A sessions, you can contact us via email fme@globima.pl. Once again, thank you for your participation and the speakers for their presentation. See you at the next events. Have a great day or evening.